All right, so they're going to either explicitly or implicitly give you information. Explicitly means they're coming straight out and telling you exactly what that thing has to be. Right here, are they explicitly telling me my center? Yeah, they tell me my center is at 1, -3. It has to be that, okay? But they're implying, they're being implicit with what my radius is. There's nowhere throughout the problem they say, hey, your radius is 9 or whatever, right? Okay? I have to determine that, okay? And that's what all these problems are going to be throughout the day. And anything that you would ever see with these is that they hide information to you. And you got to use your skills, your geometry skills, and your algebra skills, to pull out or shed light on that hidden feature, okay? So as I'm looking at this, what is my center? 1, -3. So we can start writing this equation as x minus, so you said the center is 1, -3, so it's always x minus that 1, and then y minus that -3, minus the -3 becomes +3. So we got that side, but I still don't know what my radius is. I don't know r squared then. When they provide you a point on your circle, they want you to use the distance formula to find your radius, because counting will probably mislead you in regards to what your radius really should be. So in this case, we're going to want to use the distance formula between that point there and that point there. We want to find that segment. Would you guys agree that that's r? Okay. In the distance formula, all you got to do is take that value minus that value and square it, right? So that gives you 1. And then you take that value and subtract them. 5, and then you square that and it gives you 25. So you add those together, right? And what's that give me?
26.
Radical 26. And that's r, correct? So what do I have to put in my formula?
26.
26. I got to put r squared. So there's my equation. Does that make sense? Okay. And I want to make sure that we understand and draw the comparison between that equation and potentially what we would have come up across if we inadvertently counted over to get our radius instead of doing the actual distance formula. So we found, what was it, x minus 1 squared plus y plus 3 squared equals, you said, 26, right? Okay. Would you guys agree if I put 2, 2, 2 shows up on that circle, right? Okay. Now, some people, because it's convenient, it's easy, and when I look at this, they want to count over and say, well, that point right there is 1, 2, 3, 4, 5 units from the center. Okay, so they're going to say r is 5, so r squared would be 25, right? Which is very similar. We had x minus 1 squared plus y plus 3 squared equals 26. If I put 25 there, is that a different circle? Yeah, if I put 25 there, let's see what that would look like here in GeoGebra. 25 there. Okay, so it gives me the red circle. If I zoom in on 2, 2, is 2, 2 on that red circle. Yeah. Okay, now the red circle is a pretty good approximation for the black one, right? But they're not the same circle. Okay, and that's always something people struggle with because they want to count, because they think, well, that's an intersection of grid lines. Okay, just be careful with that. Is that okay with everyone? So then they start asking you, can you go in reverse order? If I look at question number 25 there, can we figure out what the center is? what would the center be in this question? -7, 5. Okay. And if you're going in this order, I guess kind of a cheating idea or concept is whatever that number is, you take the opposite of it for your x value, right? Okay. Whatever that number there is, you take the opposite of it for your y value. Okay. Because the formula is x minus h, right? So x minus a -7 is the only way I can make that a plus. Okay. And then the radius in that case would be 4. Okay. What if I look at 26? What is the center for 26 going to be? 3, -8. And what is the radius going to be? Okay. What about 27? What's the center going to be? -4, 1. And the radius is 5. What about 28? 0, 0. Radius 6. That's pretty easy, right? Okay. Now, you could probably do the same thing from a picture. Okay, if I were to give you a picture and you're able to recognize exactly what the radius is, maybe by counting, and know exactly what the center is, maybe you could, create your equation from a picture. Is that all right? I want to do some here that are not as explicit. So if I look at questions 37, 38 here. It says, write an equation for a circle with the diameter segment AB. Okay. They didn't give me anything I need here. They didn't give me my radius. That's my formula. They don't say radius anywhere up there. And they don't give me my center. Okay. So I have two unknown things here, but through maybe a quick sketch and a little bit of logic, we should be able to determine those two components. When you draw a sketch for these things, it doesn't have to be great. I never make scales on my x and y axes, and that's usually just in general. No matter what math I'm doing, I usually don't, when I plot 8, 6, I don't count over 8 and up 6. I just know it should be in what quadrant. First quadrant, and I know I should go over a little bit more than what I should go up. So maybe that's B. Okay. So they're saying that that distance right there is our diameter. If I'm trying to fit into this, and they give me information about my diameter, how does the center relate of the circle relate to the diameter? Would you guys agree that my center should be right there? And that is the what of that segment? Midpoint. You guys remember that your midpoint is found by taking x1 plus x2 divided by 2, y1 plus y2 divided by 2. So if I do that here, it's kind of easy because we're centered, or we got an endpoint at 0, 0. So 8 plus 0 divided by 2 would give me 4. 6 plus 0 divided by 2 would give me 3. So now I know x minus 4 squared plus y minus 3 squared should equal my radius squared, but I still don't know my radius, right? But whenever they give me 2 points, you have the ability to find distance, don't you? Can I find either one of those blue or purple distances to find my radius? Now, which one do you think would be most logical to find? I would find the blue one, because that is going to incorporate values of 0, right? And when we subtract x values, subtracting 0 is an easy thing to do, right? It's trivial. Subtracting 0 from y is trivial. So we'll take 4 minus 0, gives me 4, and I'll square that, right? And then I'll take 3 minus 0, gives me 3, and square that. So it gives me radical 25. Now, if you want to, go ahead and simplify that. I would not, because what goes in the formula? R or what? Does R go in the formula? No, R squared goes in the formula, right? So if I square r and then square radical 25, what's the square of radical 25? 25. So if you simplify this, you would get down to 5 and then square that and get back to 25, right? You kind of undo some of that math, which on perfect squares isn't a big deal. But let's say that I found maybe one of my questions r to be radical 192, and you go through all that work we did yesterday, and you found out that, well, that's 8 radical 3. But now to put back in my formula, I can go square that, which means then r squared is 64, radical 3 squared is 3. What's that give me? 192, right? Wouldn't it just been easier to square that thing right away? My 192? Okay. So just be thoughtful of what your procedures are going to do for you in regards to maybe saving you a little bit of extra, ultimately useless work. Okay. You can graph that. Okay, you can go to Desmos. And type in our equation that we just came up with, which was what, x minus 4 squared plus y minus 3 squared is equal to 25, right? That's what we came up with. How can I check to see if that's right? Okay, fill in what coordinates? Well, think about what points did you know should exist on this circle? What points did they start you with? 0, 0, and 8, 6. If I plot those, do they both show up on my circle? Yeah. Where if I would have accidentally, because this happens a lot of people forget to square the 25. So maybe they left it as just 5. And I graphed that, and then I graphed the 2 points that I know I should have had on my circle, because they said that A and B had to be endpoints of my diameter, right? So by definition, that means those endpoints need to be on my circle. There, I'm seeing that they're not on my circle, right? So I've made a mistake. You could also type in 4, 3, and I would, because if I do make a mistake, at least having the 4, 3 there does show me that I've got a circle centered at that point, and now it just tells me, well, then the place I've messed up is my radius. Okay. Does that make sense to everyone? The next one is the same approach. Okay, so why don't you guys take a minute and see with these points of 3, 0, and 7, 6, can you come up with the equation of that circle? All right, so we go through. Did you guys find the center to be a 5, 3? Okay, so that was adding that x value and that x value divided by 2, right? And then you do the same thing with respect to y values, divided by 2. So in our formula, it becomes x minus 5 squared plus y minus 3 squared, right? Now, to find my radius, which radius would you rather find? The purple one or the green one? Purple. Why the purple one?
It has a 0.
It has a 0. Some of these questions, guys, you might have all non-zero values for your x's and y's, then it doesn't really matter, right? Okay, so maybe you then choose the ones that have smallest integers or whatever, smallest x and y values, just to make your maybe your mental math a little bit easier. But if I take 5 minus 3 gives me 2, square that, you get 4. Add to it then 3 minus 0 squared would be 9. Okay, so remember that's r, correct? So what is r squared going to be? Would you kind of
13.
13. Okay. Yeah.
Because you gotta do add 7 plus 3 divided by 3.
Okay, you take the 7, you take the x values, you got to add them together, and then divide by 2. So there is our equation for that circle. Now, I highlighted the yellow thing up there. What's the yellow thing for our circle? A diameter. Anybody use the diameter to find your r value? Good, because it's more work than necessary, but it is something you could do. Could I take, 7 minus 3 would be 4, right? Square that. And 6 minus 0 gives me 6, square that. Put that underneath the square root, right? we get radical 52. Okay? And that is my diameter, correct? What do I need to do with that to find my radius? Divided by 2. So we get radical 52 all over 2. That would be my radius, right? That would be R. Okay? Where that doesn't look anything like radical 13 right now, right? If I did a little bit of work there, anybody know the first square divides 52? How many decks of cards, or how many suits are there in a deck of cards? 4. And each one has how many cards in it? 13. Okay? So that would give me radical 4 over radical 13. So radical 52 breaks down to that. But what's radical 4 the same as? 2. So now what happens to the 2 on top and the 2 on the bottom? Cancel. And it does leave me R to be radical 13, right? Okay? So you got to do a little simplification there. Now, if you go that route, great, that's awesome. But I don't need R in my formula, do I? I need R squared. So what happens if I just square that, and I come over here and square that? What's the square of radical 52? 52. What's 2 squared? 4. What's 52 divided by 4? 13. And that is equal to our R squared, right? So maybe that's the way you could do it, okay? Obviously, those are a little bit more work than is necessary. It's a lot easier just to find the radius, right? But I do know some people kind of maybe feel more comfortable finding the diameter or think that it's necessary to find the diameter. So that it is a valid approach, just a little bit more time consuming. All right, I don't want to do that one yet, so just delete it. Let's do that one. Write an equation of a circle with area of 36 pi and center at 4, 7. Okay? And this is just another way that they can hide information to you. Okay? So what do you think, if I look at the center, okay, that's going to provide me x minus 4 squared plus y minus 7 squared, right? So what are they hiding in this area here? They're hiding, yeah. I don't know what just happened there. I couldn't swallow. They're hiding the radius, okay? So how do I pull that radius out of the area 36 pi? Does anybody know the area formula for? Right, okay, so area is equal to pi r squared for a circle. Well, if those are both area, what is the relationship between those two things? That's right, so I get 36 pi is equal to pi r squared. Now, you could solve for r, but what goes in your formula up here? R squared. What's in this formula? R squared. So doesn't it make just sense to solve for r squared down here? How do I do that? Yep, divide by pi. Divide by pi, they cancel. R squared is 36. So now we have that equation. Okay. Desmos doesn't do this, but GeoGebra does. I believe when I put in a circle, it'll tell me the area of it, maybe. Try real quick. So we're at x minus 4 squared plus y minus 7 squared equals 36. Okay. Maybe it doesn't. I guess I had to mess around and see if it gives me the area. Can we do it this way? 113.1, okay, which 36 pi. Let's see here if it does it this way. Let's just take 36 times 3.14. Get an approximation. Would you guys agree those are probably the same then? Okay. So they're implying what your radius is. Sometimes they'll imply what your center is. I had one up here that was that. Let's try to do that one. Write an equation of a circle with center 4, 7. So using the same center. So I think we get that concept, right? The center is always going to be x minus h squared plus y minus k squared. But now it says we want the circle to be tangent to the line y equals 12. Tangent to the line y equals 12. So what are they hiding there? Hiding the radius. But the way that you're going to have to do this, the way you have to figure this out, is to draw a sketch. Draw a little bit of a picture here. Okay? If I've got a center at 4, 7, so 4, 7, maybe that's there. Okay? And that's going to produce a circle, right? So maybe that's my circle. Okay? Now, what does the word tangent mean to us? What does a line that is tangent to a circle mean? It only hits at one point. Okay? What does the line y equal 12 look like? What kind of line is it? It's horizontal. Horizontal and going through what y value? 12. So that's 12. There's our line y equals 12. If they're tangent, that means they touch one time right there, correct? What's the ordered pair for that point? 4, 12. It has to be vertically aligned right there, right? So now our radius, would you guys agree that your radius is that distance there? How do I find that distance? Subtract your y's. 12 minus 7 gives you 5. So what goes right here? 25. Okay. Could I change that question by saying that I'm going to be tangent to the line x equals 13 or something like that? If it's x equals, what kind of line is that? Vertical. Okay. We can actually do any line. It's just a lot messier when I want to do a line that has a slope other than 0 or undefined. So we'll try to avoid those at the moment. All right. So from there, we'll pick up with the last concept here. I'm going to do a little bit of algebra here to get us in the mindset of what we're going to try to do with this type of question. What if I start with, if we have x minus 4 squared plus y minus 7 squared is equal to 25. What does this really mean? What is the algebra that is actually stating that I should be doing? I should FOIL that. Okay, so that means x minus 4 times x minus 4. For the same reason, this means y minus 7, y minus 7. And I got my 25, obviously. And if I did FOIL these, it gives me x squared minus 8x plus 16. FOIL these, gives me y squared minus 14y plus 49. I got my 25. Would you agree that 16 and 49 are like terms? And that's 65 total, right? Is that a like term as well? So let's move that 65 to the other side. And I get that. Does that make sense? That blue equation and this red equation produce the exact same circle. Okay? So I'll give you a minute to write that down, and as you're writing that down, I'll do something over here in GeoGebra real quick. All right, so just typed in x minus 4 squared plus y minus 7 squared equals 25, right? GeoGebra
allows me to change the format of the equation, and it changes it into that. Is that exactly what we came up with right here? Okay, so they both produce, if I were to graph this, they're both producing this circle centered at 4, 7, okay? And if they're centered at 4, 7, it has a radius of, and that distance right there, a radius of 5, okay? So here's where I'm trying to lead you to. What if they present me in a problem with the equation like it is up there in GeoGebra right now, and they want to know what the center is and what the radius is? How do we algebraically do that? Okay, so let me just create a different equation here, and we'll mess around with it a little bit. Let's go that, and let's go 3, and all right, so let's say that I start you off with that equation, and I ask you, can you start with x squared plus y squared minus 4x plus 6y equals 3, and can you tell me what the center and the radius of that circle are? Okay, and that's a little bit harder of a process, right? Okay, but think about what we just did. When we expanded that last equation, and it turned it into something that looked like this, the process that we went through was foiling, right? We foiled and then we just added like terms, correct? Well, now I'm starting at this end of the problem and trying to get back to the other format, okay? So previously we foiled. How would I go in reverse order? What algebraic process? What is the reverse or the inverse of foiling? If we know that x minus 4 squared is equal to x squared minus 8x plus 16, how can I start with x squared minus 8x plus 16 and get back to x minus 4 times x minus 4? What undoes foiling? Factoring. Okay? So with something that starts off this way, what you need to do is factor. Okay? Now, our factoring techniques are going to be difficult for us. Okay? Like two numbers that multiply together, give me my C term, not give me my B term, or quadratic formula, or anything like that, are hard in this situation. And what we actually have to revert back to is the concept, the algebra that actually develops those shortcuts. We got to look at completing the square process. Okay? So maybe last year in Algebra 1, you asked the question, okay, if I can use quadratic formula, I can use these shortcuts, why do we ever learn to complete the square process? This is one of those reasons, because it's unavoidable in regards to if I start with this equation, how do I start graphing this thing efficiently by knowing the center and the radius? I have to complete the square. And what happens here is because we got two variables, we actually have to complete the square twice. Okay? So what you want to do is you want to rearrange your variables so that your x's are together. So I'll rewrite this as x squared minus 4x. So I've used that, and I've used that. Then you're going to go plus, and just leave a spot right there. Okay, that's kind of a placeholder for the completing the square process. Then I'm going to go with my y squared. And in this case, we got plus 6y. And I'll put plus again and leave a spot. And that should then equal 3. I want to make sure that all my constants are over here. So every time I do one of these guys, it's going to be an x squared and an x, a y squared and a y. You're going to have a spot after each of those. And then over here, you're always going to have your constant, okay, by itself. Completing the square is going to be done right here with those terms and then again right here with those terms. You guys remember how to complete the square? Do you remember what you do with that number right there? Divide by 2, and then completing the square, square it. Okay, so divide by 2, and then square that. So negative 4 divided by 2 is negative 2. Negative 2 squared is 4. You just added 4 to the left-hand side of the equation, right? To keep it balanced, you need to add 4 to the right-hand side. Okay? So you just completed the square with x's. Let's complete the square with our y's. Take that number there, divide it by 2, gives you 3, and then squared gives you your 9. Add 9 to the left, I'm going to add 9 to the right. And the reason we do this is because this thing has now become a perfect trinomial. And a perfect trinomial means it can be written as x plus or minus something squared. And that plus or minus something that we have to decide is that first thing we did to that negative 4. We took what of that? Half of it. So what goes in this spot is always half of that middle term. So x minus 2. So now I've got x minus 2 squared. And think about, does that make sense? This thing here is just a rewritten form of that. X minus 2 times x minus 2. If I go to the side and I FOIL that, x times x gives me x squared. I get negative 2x, and I get positive 4, right? Is this thing here the same as that? Yeah, it's just a better version of it, a better way of writing it. Now we're going to come over here and do the same thing for our y's. Okay, so this is a perfect trinomial as well. So we'll go y, and then it's plus half of that, so plus 3, and then squared. If I go y plus 3 squared, y plus 3 times y plus 3 gives me y squared plus 6y plus 9. What's this right-hand side turn into? 16. What's the center of this circle? 2, negative 3. What's the radius? 4. Okay. So completing the square is going to allow us to take that uglier format and reposition things, rewrite things so that it is it's in that circle equation format. The center, a lot of times called the center radius format. Okay. Because if I look at this thing here, and you're going to learn in Algebra 2, you're going to deal with this a little bit more on a little bit of a deeper level. But if I look at that thing right there, can you pull out a 2 and a negative 3 from that? Can you pull out a radius of 4 from that? You can't, right? Okay. But when I write it in the center radius format, we can pull those values out pretty easy. You're going to see maybe a couple of those in your homework this evening, okay? Which is due on Monday. On Monday and Tuesday are shortened periods, okay? We should be a 2-hour delay, right? It's a 3-hour? Okay, so 2-hour delays on Monday and Tuesday, so the classes are going to be shortened. We're going to be a quick pace in those two periods, talking about area of circles, arc lengths of circles, and stuff like that. And then maybe Tuesday through Friday, try to introduce you to areas, maybe some quick volumes. The last class was talking about reference sheets for the end of course exam, and they look like this. They're on Ohio Department of Education's website. Your reference sheet is going to look like this, where it gives you basically your conversions, okay, so some useful conversions that you might need. There's your trigonometry stuff, SOHCAHTOA in that first box. Special right triangles in the second 2 boxes. And then the last one, okay, is just all your area formulas and volume formulas, okay? And to read those, it gives you kind of a key up there at the top. That B represent, every time I see a lowercase b, it's talking about a base. When I see a capital V, it means the area of a base. When I see H, it's the height, and R is the radius. Okay? And we'll talk about then, how do I determine shape what a base is, how do I determine shape what an H is, that kind of stuff. Okay? That'll be what we do next week.
It really looks like losing your basketball. Oh my gosh, he does.